since I can't sit next to you and go through it with you with a real protractor, we'll have to use this digital one. So I don't know if you can see, you can drag it around and the little, when you click on it, there's like a little spin button so you can turn it round to however you want as well.
Yes.
So if you want to have a go at working out the angles of number 1, 2 and 3, that would be fab.
Okay. Okay, so start on this one. There, so 90.
Yeah, spot on, okay. So remember, we need to line either side up with the 0.
Yeah.
So we'll need to rotate that.
Oh, I know, okay, right.
Yeah.
Then
Yeah.
line.
I'll try not to tell you too much to give you the good wise.
So.
Yeah, spot on. So we want to line up that middle bit where the cross is. Yeah, on the corner of the angle. Brilliant. On where the two lines meet.
So 180 and 150.
Yeah, so you've done that perfectly. You've lined that up perfectly. But can you see? So we've got 180 here. But because we don't need it on this side, we can use this blue 0. So we can use the inside blue numbers.
Yes, so 30 and 0.
Yeah, so it's going to be 20, 1, 2, 3, yeah, like 28, 29, 28 and a half maybe.
Yes.
Yeah, brilliant. Excellent, really, really well done. And then do you want to have a go at trying to find number 2?
Yes. Rotate this. Like this.
Yeah, so this time we'll need it vertical. Yeah, brilliant. Okay.
The other way.
Look, yeah, we'll need it the other way. Yeah, brilliant. I was just about to say that.
There.
Yeah, and then line it up.
So,
brilliant. Then can you see this time we've got it so that our line is lined up with the black 0. So we'll use the scale on the outside.
Yes. So
yeah.
0 and 60.
Yeah, so that one's pretty much spot on 60, isn't it?
Yes.
Yeah, brilliant. Excellent. And then don't I've got the last one, number 3?
Yes. Here. Like this. Just turn it around.
Yeah, line it up. Yeah, brilliant. And then the 0 is the black 0, so we'll use the scale on the outside again.
So it's going to be 141. No, 140. Something.
Yeah, it's like 141 and a half, isn't it?
Yes.
Yeah, brilliant. What would we do? Yes, just an extra question. What would we do if the angle that we wanted to measure was an angle like this one? Hang on.
You would have to do the other side.
Yeah, we could use the protractor to work out the angle of the underside, and then what would we have to do with that?
You can, and then it has to be 360. Each side is gonna be the same.
You're right, you were right the first time. So we subtract that blue one from 360, don't we?
Yes.
So I'll just try and draw that as best I can. So we subtract the blue angle to get the, I don't know if it's a grey angle or, well, it's green now.
It's green.
So we subtract the blue angle from 360 to equal the green angle. Because those two added together create a full circle, which is 360 degrees.
Yes. Yes.
Yeah, really, really good. So we can use these little half protractors to find any angle. You might have seen though, you can get full circle protractors, but they work exactly the same as this. You just line them up in the middle and line them up with the zero, and you can count the angle the whole way around.
Yes.
Okay, so moving on to bearings. Can you remember any rules for how we take a bearing from something?
Oh, so
It can be anything at all.
So the digits have to be three digits.
Yeah, brilliant. It has to be 3 digits. If I took a bearing and it was 60 degrees, how would I write that?
060.
Yeah, excellent. Really good. Anything else?
When you're doing the other side, it's gonna be the same.
Maybe, possibly. Say that again, sorry.
So when you're measuring, so say there's like a circle, and then let me just draw.
Yeah, draw. Go on.
Like this. So say there's an angle like this, like that, and there's this over here, and then like this, and say this one is 70 degrees.
Mm-hmm.
Yes. The other side will be the same, 70.
Yeah, so that's true if the angle is made up of two lines.
Yes.
And the lines run through each other, so you're totally right. In the case where we've got 2 lines, opposite angles are equal to each other. So if one side was 70, the other side would be 70. And actually we can work out what the other angles would be. If both of those angles were 70, what would the blue angle be?
70, 14. It would be 70. The 360 has to add up 70. 140. Hold on.
Yeah, no problem. No rush.
140. 110.
110, brilliant. Yeah, 110. And both of those would be 110 because they're both opposite each other.
Yes.
So that's definitely true for angles. Opposite angles that are made up of the same 2 lines are always equal. The other 2 rules for bearings, I'll give you another one. And then you can tell me if you can think of the third one. We always take a bearing starting from north. Remember that from the other day?
Yes. Yeah.
So
Yes.
Yeah? And what's the last one, do you think? What will the last one be that I'm looking for?
The sides. So say if you're gonna so the north side and say D and C, yes. If you want to get the this C like that, and north here, C and D.
Yeah.
To get here, and this, 110. You want to find out what D is?
Yeah, we want to take a bearing to D, yeah?
You have to get the protractor and this, and then you have to measure from north to N to D.
Careful. So that is true, but you've done exactly the opposite of what the third rule is. Can you work out what it is?
No.
So keep that on, keep it on. So we've got C and D and we want to take the bearing.
Yeah.
You're spot on, we start at north But instead of taking the bearing this way,
The other way.
yeah, we take it the other way because we take a bearing always from clockwise.
Yes.
So the bearing from C to D would be from north all the way round clockwise to D.
Yes.
Yeah, does that make sense? Is that ringing a bell from Wednesday?
Oh, yes. You have to do from there.
Always has to be clockwise. And the reason for this is just because bearings are used in for people who are sailing like ships, for example, or maybe people who fly aeroplanes.
Yes.
So it's really important that the bearings are accurate and that if I said a bearing to you, you would be able to replicate it exactly if you were flying a plane or something. Does that make sense?
Yes.
Yeah, so the conventions are it always starts at north and then it always goes clockwise.
Yes.
And the 3 digits is because I believe that it's because if I said to you, the bearing is 60 degrees,
Yes.
you might misread that. Whereas if I said to you 060, you know that you're always looking for 3 numbers, no matter what.
Yes.
And if it is 60, then it's going to have a 0 in front.
Yeah.
Instead of confusing it, you might think I'd said 160 or something instead. I think that's why.
Yeah.
Okay, so now I've got 2 little exam style questions.
Yes.
If you want to have a go, so one of them, the first one, which is labelled number 2 confusingly, you'll need the digital protractor for, but number 5 you'll not need the digital protractor for.
Okay.
So have a little go.
So it has to be clockwise. There's 90. Will it be this way? It's 90. To go to north to be.
Going all over. So you line it up, yeah, and then do you remember? So we take a bearing, we need to line it up with north, starting from 0, don't we?
Yes.
Oh, actually, so this is really similar to what we discussed. I'll draw a little line to it. Hang on. Follow my red line. Here.
Coming.
So scroll up. Yeah, so can you see that the angle that we're trying to take the bearing of
Yes.
is the one that's clockwise from north,
Yes.
but it's over 180 degrees, isn't it?
Yes.
So there's 2 things that you can do. You can either take the bearing of the green part and subtract it from 360, or you can say, right, well, I know that from the bit that I'm shading in pink now is equal to 180 degrees, and then work out the bearing of just the red bit and add it to 180.
Okay. Oh, okay. Yes.
Yeah, does that make sense?
Yes.
Have a little go. You choose whichever method you'd like to do, and I'll give you a hand.
So we know the straight line, which is 180.
Yep.
So we need to find the green and the red.
The green or the red. So if you find the red, we can add that to 180.
Okay.
If you find the green, we'll subtract that from 360.
Okay.